Wiring this into CI is straightforward. Layer 1 and 2 tests run on every push, using only committed files. No secrets, no API keys, no network calls. Layer 3 tests are marked with a PyTest marker and run only on merge to main. The fast layers block the merge on failure. The judge layer notifies. This keeps the per-commit cost at 0 while still running semantic checks on every meaningful change. Welcome back. This episode is about a gap that affects almost every team shipping LLM features. No tests for what the model returns. You have unit tests for the code that calls the model. You have integration tests for the API layer. But the model's output itself goes untested, and the first person to notice a regression is a user. Today we're going to fix that. The gotcha with the judge layer is shared blind spots. If you prompt the judge to evaluate whether a summary is good, it will probably score most summaries highly, because it was trained on the same data distribution as your classifier. You need explicit, measurable criteria. Not is this good, but does this summary include every dollar amount, date, and account ID that appeared in the ticket? That specificity is what makes the judge useful instead of a false confidence generator. The first layer is structure. If your model returns JSON with a category field, that field should always be present. It should always be one of your defined enum values. It should never be null. These constraints are completely deterministic and testable with standard PyTest assertions. You load a directory of saved responses, your golden files, and run assertions against every field. No API, no network, runs in under a second. Most teams could ship these tests today with code they already have. The third layer is the LLM as judge. For failures that structure and regression tests can't catch, you use a second, stronger model to evaluate quality. The judge gets the input, the output, and a set of explicit criteria. Does the summary mention all numeric values from the ticket? Is the category consistent with the description? The judge returns a score and an explanation. If the average score across your golden set drops below your threshold, a human is notified. This layer runs on every merge to main, not on every commit, because it has a small cost in API calls. The second layer is regression. When you update a prompt, you regenerate the golden set by running your test inputs through the new prompt. Then you compare the new responses to the previous ones. If a ticket that was previously classified as billing is now classified as account, that's a regression test failure. A human looks at it. Maybe the new behavior is correct. Maybe it's a bug introduced by the prompt change. The test surfaces the question, a human answers it. This catches the subtle failures. The category that changed, the priority that drifted up by 1, the summary that started omitting certain fields. The instinct to reach for exact match assertions makes sense coming from a traditional software background. If a function returns a specific string, you test for that string. But LLM outputs are different. The model might use a synonym, change the order of a list, or add a clarifying phrase. Exact match fails, so teams give up on testing the output entirely. That's the wrong conclusion. The right move is to test at the right abstraction level. If I had to give one takeaway from this episode, it's this: start with the golden set today. Run your test inputs through your current prompt, save the JSON responses to your repo, and write 5 structure assertions. Commit that, you now have an eval baseline. Every future prompt change runs against it. The layers after that, regression and judge, build on that foundation. But you need the foundation first. Thanks for listening. Full code is in the post linked below.